there are m options for the first event, and when we say event, it's like a choice or first thing that we're doing. Shouldn't be a comma yet, sorry. And n options for the second. And then we'll put a comma there. Okay, now when I say m options for the first event and n options for the second, remember those are variables. And variables represent numbers. So when we are actually talking about this, we're not saying like, how many choices do you have for drinks? And you're like, I have M. That wouldn't make sense in real world. We'd say we have 3 choices. So these are going to be numbers once we figure this out. Okay. And so to do that, our total outcomes, so our sample space, is m times n. We just multiply our amounts. And again, this works really well if we have the same amounts for every decision that we're making. Yesterday it didn't work well because yesterday it changed into different amounts each time. But today it'll work well because we'll have the same amounts every choice that we make. All right, so we're going to do 3 problems. We're going to go by pretty quick. So make sure you got that written down. See a couple of people still writing. Give you a second. All right, so number 1. I want to know how many outcomes are there if we roll a dice 7 times. So today we're going to just find the outcomes. We're not going to do probability quite yet with these outcomes. We're just going to find the total amount. So if I was going to do a tree diagram for this, I would list out my first roll. When I roll a dice, how many options are there? A normal dice? 6. So I'd have to 1, 2, 3, 4, 5, 6. Then if I rolled a 1, could my second options be? What would I get on my second roll? 1, 2, 3, 4, 5, 6, right? It would be turned into this really, really big tree diagram. It would be so much. So we don't want to do a tree diagram every time. So what we're doing is we're doing it 7 times. So I want to say how many options do I have on my first roll? What did we decide? 6. Okay, times. Now it's my second roll. So this was my first roll. Okay, now on my second roll, if I rolled a 2 the first time, can I get a 2 the second time also? When I re-roll? Yeah. So how many options are there in the second roll? Yeah, 6 again. And on the third roll? 6. Fourth roll? Yep. And we're doing that how many times? 7. 1, 2, 3, 4, 5, 6, and 7. So we have 7 times we're rolling that dice. Come on, boom. Okay, if you wanted to write like first roll, second roll, third roll, you can. I'm just going to stop at the second roll there. All right, now you could type this into your calculator, 6 times 6 times 6 times 6 times 6, but then you maybe zone out in the middle like I just did, and I don't know where I'm at. So another way to write this is with an exponent. What would be the base of the exponent? What am I multiplying? 6. And how many times am I multiplying it? 7. So it'd be 6 to the 7th power. Okay, and then we're actually going to throw that into Desmos. So either way, kind of up to you on how you want to write that. I prefer this way, if it's the same number over and over again. Okay, so 6, 6. And then remember the power button on Desmos is this AB button. Okay, so AB, 7. And we end up with a lot of outcomes. So 279,936. All right, those of you that haven't had me yet before, I always box my answers. We haven't really had problems where we box our answers yet. That's what I do. I was taught to do that in 6th grade, otherwise they wouldn't count my homework right. So I just do that. You don't have to. All right, so remember we're rolling dice. It could be 1, 1, 1, 1, 1, 1, 1, 1, or it could be like 1, 1, 1, 1, 1, 1, 2, 1, 1, 1, 1, 1, 1, 3. To list that all out would take us a really long time. So that's why we have our fundamental counting principles, to make sure that we don't have to do all of that. Okay, number 2. We're almost done, Kia. Just wait until we're done with notes. You'll survive. 3. All right, number 2. All right, now we're going to take a test. Okay, on your test, we're not actually taking a test, so chill. Not yet, anyways. Test is about 2 weeks away. The test, we have 2 questions that are going to be true or false. So the first 2 questions are true or false. Then we're going to have 3 questions that are multiple choice. You guys take more tests than I do these days. How many options do you guys usually get on your multiple choice? Usually do you guys just do ABCs or 4? A, B, C, D? Okay. That's what I thought, but I just wanted to make sure. So I want to find out how many ways could we have the test filled out. Okay, so as I look, we're going to have how many, our events this time is our questions. So how many questions total are on this test? 5. So I'm going to make 5 little spaces here. I'm going to say Q1 for question 1, Q2, Q3, Q4, Q5. Okay, so we have 5 questions. Now we're saying how many options we have for each question. How many ways can we answer the question? So question 1 is what type of question? The first 2 questions are true or false. So in a true and false question, how many options do you have? 2. It's either true or false. What about question 2? How many options? 2 again, right? True or false. It's okay if it's true, true. It could be false, false, true, false, false, true. Okay, but once we hit question 3, it's now multiple choice. So how many options are there for question 3? How many? 4. We have our A, B, C, D. 4 questions. Or sorry, 4 options. Okay, question 4, how many options? No. It's multiple choice. A, B, C, or D. It's still just 4. All right, question 5, the last question is multiple choice. How many choices are there? 4. Didn't change. So to find our total amount, we're going to multiply these numbers. So 2 times 2 times 4 times 4 times 4. Okay, when we do that, we end up with 256. So those of you that when you go into a test, some people, There's 256 like versions of the test that we could do. Some people, they're like, oh, it's just true and false, or it's just multiple choice. I'll just go in and guess, right? Like, if it's all true and false, I have like a 50% chance of doing it right, right? Okay, but if you just randomly guess on that test and you say one of your versions out of 256, you have almost a 0% chance of getting it right, 100%. Okay, so I know it feels like on multiple choice and true and false, you're like, oh, I'll just guess. I have good chances of guessing right. On a big test, your chances of getting a lot right become really, really small. All right, we're going to do one more, but this one is actually 2. Sorry. Kind of lied when I said there was 3 examples. Technically, it's 4, but that's okay. All right, number 3. Keon. Bruh. What? Don't throw things in class. What are you doing? All right, number 3, we're going to do a password. Now, with passwords, we have to be careful if we can use lowercase, uppercase letters, if we can use numbers, if we can use symbols, things like that. We're going to just do 4 capital letters. We're going to keep it simple for this first one. Next week, when we do different combinations and permutations, we'll mix it up a little bit. We're going to keep it simple today. So 4 uppercase letters, 4 capital letters. All right, if we allow repeats, meaning if you can repeat a letter, the password A is allowed. How many letters do I have to choose from if we're using the English alphabet? 26, yep. Now, I can repeat, so I can reuse the same letter. So how many do I have again? 26. And how many times are we doing it? How many letters are we picking? 4. So 26 times 26 times 26. Or I could write that as what? Good, to the power of 4, because there's 4 of them. Okay, so 26 to the power of 4. We get a crazy number there. 456,976. We're talking about passwords here. So if this is back in the day, 4-letter passwords used to be fine because we didn't have computers going through and doing it. If a computer was going through and trying to hack into your account and you only used 4 capital letters, there's not that many passwords for a computer to go through. They could do that pretty quick, to go through about 500,000. Okay? So that's why when you are signing up for a website, it's really annoying, and they're like, you have to have at least and this many. Because the more complex you can make it, the more passwords there's going to be, which is the less chance of getting hacked. All right, but now let's just double check. If I have no repeats, and this is going to happen to some in your quick check depending on what you're doing. So you have to decide, sometimes it's really obvious when we're doing things if there can be repeats or if there can't be repeats. So for example, if I'm running a race, can the same person get first place and second place? No. If you win first place, you can't win second place. You're out. Okay? So, but no repeats. So this time if I use A for the first letter, I can't use A again. Okay? So how many do I start with? How many letters of the alphabet can be my first option? 26. And we're going in order, so now that I picked one of those letters, I can't use it again. How many letters do I have now to choose from? 25. Good. Okay, I use that letter. How many letters are left? 24. Okay, that letter is used. How many is left? 23. So should this have more passwords or less passwords if we have no repeats? Less repeats. Yep, good, less. Because we're now taking away all those options of like A, B, C. I don't know, I said that too many times. A, B. All right, so 26 times 25 times 24 times 23. And we just did it 4 times because we're doing 4 letters. And yep, we get less. 358,800. So back in my day when the internet was first created, because technically I wasn't alive when the internet was created, but when it was given to like the public population, I was alive. They used to like not want you to repeat letters in your password because it was easier for the systems to remember, but there was fewer passwords to choose from. So everyone, it was easier to hack. So that's why old people, you know, like how old people get hacked all the time? That's why, is because the old people still use these really simple passwords. Okay, you young people are good at like knowing, oh yeah, I have to use capital, lowercase. And that's why your school passwords are so complex. You have to use capital letters, lowercase, and then usually those numbers, right? All right, cool. You guys crushed it. Okay, today's quick check is